Hello everyone, my name is Abhinav and I along with my team members Ayush and Anand will be explaining you about our project Simple Encryption with multitasking using hash tables. In this video, we will be explaining you about what is encryption, how does it work, what are the various algorithms we can use, and how we inculcated multitasking and hash tables in the project. So starting off with what is encryption? Encryption is nothing but the process of converting a given plain message into a coded format protected from unauthorized access. It ensures data confidentiality and security. Encryption uses algorithms to scramble data in a way only authorized parties can access. There are majorly two types of encryption: symmetric encryption and asymmetric encryption. In symmetric encryption, only one key is used for both encryption and decryption, whereas in asymmetric encryption, pair of private and public key is used. How encryption works: the data to be encrypted is taken from the user, and then the algorithm scrambles the data into an unreadable format, also known as the ciphertext. Only authorized users with the correct key can decrypt the ciphertext. Keys ensures only intended recipients can access the information. Various algorithms include AES, RSA, and DES are used for encryption. Why is encryption important? Encryption protects our privacy. It prevents unauthorized access and it also secures the communication. It is used in various messaging apps like WhatsApp and Telegram. It also secures our online transaction details. It complies with regulation, meets GDPR, HIPAA, and other legal requirements. It also secures cloud storage, encrypt files while stored online to prevent breaches. It prevents data breaches, safeguards against hacking and data theft, and marks as a foundation of cybersecurity. The further explanation of how encryption works, how multitasking and hash tables was inculcated, will be continued by Anant and Ayush.
Hello everyone, my name is Ayush Kumar. So let's get started. How my encryption works? Encryption process. So encryption process is basically a process in which series of operations that securely transform the input data into an encrypted form. It includes the following stages: input conversion, key generation, parallel processing, XOR encryption, and hashing. So first in input conversion, the input data which can be in text, decimal, hexadecimal, or any other format. It is necessarily because encryption operates at a binary level, similarly to how data is processed in digital system. Next, key generation. Whenever we are doing the encryption process, there is a key which we need to encrypt a particular data. So in this, we have used OS module, which is os.ur random, and the generated key would be around 16 bytes long, providing 128 bits of security. The key is very crucial for the XOR encryption to ensure high integrity in the encryption process. Next, also we have a parallel processing in which there are two tasks which are performing simultaneously. So in this, the task one which would be XOR encryption is performing the binary data using the generated key, and simultaneously the encrypted data is hashed using the SHA-256 algorithm for secured storage. These tasks are executed separately in each process, which are working simultaneously. Next, we have XOR encryption. The binary representation of the data is XORed with the binary representation of the key. It scrambles the data and it is unreadable without the key. Next, we have hashing. All the data which we have are hashed individually. After XOR encryption, the data is hashed using a SHA-256 algorithm, which makes it a fixed size hash value, and the hash will be entirely different, allowing for detection of any unauthorized changes. The hash value is then stored in a hash table rather than encrypted data itself. Next, XOR encryption. Now, in XOR encryption, the basic concept is that there would be binary operation using encryption for each bit of data and the key. The XOR encryption operation outputs 1 if the bit are different and 0 if the bit are the same. Next, we have the process. The input data is processed bit by bit with a key. If the key is shorter than the data, it loops to match the length of the input. Next, we have reversibility. XOR encryption is symmetric, meaning the same key used to encrypt the data can also decrypt the data for the user. Next, we have purpose. XOR encryption is very simple and computational efficient, so which makes it suitable for real-time application. Now, hashing with hash tables. The purpose of hashing is basically to store encrypted data in a fixed length hash value. The value uniquely represents the input data and ensures data integrity, which is computational, infeasible to reverse a hash to retrieve the original data. The hash acts as a unique fingerprint of the encrypted data. There are a few steps in the process, which are: first we'll do the XOR encryption. The data is encrypted with the SHA-256 algorithm. Resulting hash value is used as the key in the hash table. Next, we have the encrypted data itself is stored at the index determined by the hash value in the table. This allows a very efficient flow of data along the whole thing. Next, we have few benefits such as basically enhanced security, data integrity, efficient storage, and immutable representation, which each of them stands like in a unique way. Which, for example, enhanced security, which gives you uh, without the key you cannot read the data, and data integrity is basically hashing ensures that slightly alteration in the encrypted data is detectable, because if there is any change in the key, you cannot actually access the data. Next, we have efficient storage. We are using hash tables for it. Immutable representation is basically there will be a fixed size for the whole hash table and it cannot be changed.
Hello everyone, I'm Anant. Now we'll be proceeding with how my encryption works. In encryption, we use multiprocessing. Multiprocessing allows multiple tasks to be executed in parallel utilizing the system's multi-core architecture. This improves performance by reducing the overall execution times. The implementation of multiprocessing in our project is the encryption task and the hashing task are performed in separate processes. These processes run concurrently, enabling efficient use of CPU resources and reducing latency. Shared memory, a managing director is used to share results between the parallel processes. This approach avoids conflicts and ensures data consistency. Now, the purpose of using the multiprocessing in the encryption is by separating these tasks, the system can handle encryption and secure storage simultaneously, making the application response and scalable. This improves the time reducing the time for the overall process. Now we move on to this project incorporates foundational concepts from digital design and computer organization. The next concept we use in encryption is binary operation. The XOR operation is a key component of digital logic and implemented at the withdrawal hardware level in CPUs. This project uses it for encryption, demonstrating its real-world application. Data representation. The input data is converted into binary from reflecting how data is stored and processed in computers. Text, decimals, and hexadecimal input are aligned with binary equivalents. Random key generation. Now, the key generation process uses system level entropy to create a secure random sequence, ensuring unpredictable. This aligns with hardware based random number generation in cryptographic systems. Now, the parallel processing. The use of multiprocessing mirrors the architecture of modern multi-core processors, where multiple tasks are distributed across different cores for efficient execution. Hashing operation. The SHA 256 algorithm involves bitwise operation and logical shifts implemented efficiently in hardware in modern processors. This project uses it for secure storage, ensuring the integrity and encryption of the data. Now, at the last, we move on to the conclusion of this project and to the conclusion of this video. This project efficiently encrypts user input while generating a secure hash for the data. It utilizes multiple processing or multiprocessing for performance and stores encrypted value using hash tables. Ensuring secure and organized data management, real-time terminal logs provide transparency and making it a robust and versatile tool for encryption and data security. Thank you.